Decoding 5G.Zone focuses to skill up and innovation up of an individual. That's what we wanted to really do on the 5G technology. We really wanted to make this zone as a place where we wanted to decode the power of 5G, right? So that's the thought process. Thanks to the sponsors. The most important thing here is you can reach out to support at decoding5g.zone, or you can reach out to sponsor at 5G decoding. If your company or anyone wants to help us to continue this good work, the tools and everything that we put together does cost, right? Okay, let me check here. I'll try to do this quick. I should have been better prepared there. That's okay. Excuse me because I'm not in my hometown and I have traveled to India. So support and sponsor, these are the two email IDs you can do. Feel free to unmute and ask questions. It's a live session. Then what else? There is Microsoft Teams invite. We would have already sent you for you to join. If not, you can let us know in the chat. We will send you the invite to join the Microsoft Teams Testoper channel. Then we have this one, right? Yeah, you can donate through this link. And this is the every time you wanted to join this event, this is the place that you need to go and register. One thing that we were thinking was to send you guys a meeting calendar invite because we have your email address. That's also something that we are thinking of. Probably we'll do that before our next bi-weekly. And then the last one is this is the link in case if you get disconnected, or next week if you wanted to join, you can always use the fifth link to join. But those who are very nice, you can go to this and register it and then join through that. And those who are nicer and lazy, let's say, they can just use this link and directly join the meeting when the time comes, right? So let me cut this and paste it here quickly. Right. Perfect. Now, slowly, what we will do is we'll start getting into the details of Magma. But before that, I'll talk like 10-15 minutes. And I have a new speaker from Wavelabs, Yokesh, today. And he is trying to just to give a very high level picture. Some of you, it might look like a little bit more detailed, but he's trying to give some high level picture and try to show some kind of a demo with 5G simulators, open sources that are available. I don't want to take the thunder from him, but that's a good starting point. We thought, right, from the starting to kickstart from learning Magma point of view. Let's go back to the slides. Just a refresher. There are some slides that I want to make sure that you guys understand as a refresher. So what we will try to really achieve in this decoding 5G.Zone with the help of Wavelabs is to help you guys to develop the expertise of complete end-to-end system, as well as more particularly, we have to choose something, right? We have chosen Magma as a open source that we will learn together as a team. And we'll also work together to integrate Magma with few other radios and things like that as a part of the ongoing hands-on exercise. The presenters might do, and you can actually see. And if you wanted to have an hands-on, exercise, you can also reach out to us. We'll be happy to do that. We need more people, getting hands-on and learning Magma. We wanted to really do that. So these are the two goals of decoding 5G.Zone. And what we have gone through, what we wanted to go through from the technology point of view, this is something that I will go through throughout all the 12 sessions. In every sessions, I'll try to introduce some technology. So by end of the session, along with the practical thing, you will see where you will get by end of the session for sure. Right. So we started with wireless network. We went through the wireline network. We went through the introduction of different wireline networks at a high level. And then in the second session, we started with the wireless network. And I'm not going to repeat. You can always go back to the videos, YouTube videos. Just go to Wavelabs, just search Wavelabs technologies in the YouTube, and you will get a channel, and you can just click it. You will be able to see it there. or other places, you can go to Testoper and then you can also see it there. And we are also looking at to publish that into the Magma YouTube. Once that is done, we will also let you know the link. For now, these are all the two places that are available. Just to give you the big picture, why 5G? Because it's all going to be a great opportunity for us, especially, and it's going to create, there's a number of things, right? It's going to create close to 20 to 21 million jobs by 2035, new jobs, right? And almost 10% GDP growth globally. It's going to help us with 5G enabled economy. So it's a great opportunity for all of us. And then the most important thing last week that we discussed was we were introduced at a very high level. How does that end-to-end cellular network works? It starts with the devices and then followed by all the equipments. And the equipments are kind of classified as an equipment that is radio access equipment, then transport equipment that connects all the different radio access network equipments, as well as the core network equipments, right? Then OSS, BSS, which monitors the complete network, and BSS, which kind of takes care of onboarding the customers, sending them the bills, and so on. So this is the end-to-end cellular network as we know it. And what we also went through was the evolution from 2G to 3G to 4G to 5G. That's what we went through. And what I wanted to kind of give you guys a refresher is that in every technology, there was a signaling. Sometimes it's called as a control plane, which is something connects you and me until the phone rings. And after you pick up the phone, then you have this user plane where you can communicate with each other or communicate with server, whatnot, right? So these are the two concepts that you have to be very clear, because it's going to keep on coming. And then the second most thing that you need to understand is every technology evolution from 2G to 5G, number of things started evolving, right? Before we used to do only voice, then SMS, and now 8K videos and so on. 5G promises person to person, person to machine, and machine to machine communication. It's designed for, like I always said in the previous session, connected industries, right? So those are the key things that I wanted you to remember. And finally, this was the last slide that we looked at in our previous session. So if you look at this whole thing, what had happened was from the earlier evolution to now, systems got converged, systems got disaggregated. There's no logic if you think about it, right? Every time people talk about some advantages in doing this. This is what that has really happened throughout the evolution. But the point is, depending upon the use case, you go with converged or disaggregated, all in a one box, or different function working in different places. It all depends on the use case that you wanted to do, right? And 5G is designed as a flexible system to adopt the use cases whichever way you want. Even though standard defines all these different network functions, it's not necessary you got to implement everything separately. You can always pick 3 or 4 and make it as one product, or you can create multiple small things as a separate product, right? So that's what I mean. And I'll give you another practical example, right? So 3G, you had node B, right? And then you had RNC. In 4G, what happened? Everything is converged into E node B. Now in 5G, what's happening? That is converting into RU, DU, CU. So again, it's the use case that's going to really help you to use it in a different way that you wanted to use it. But the rationale of 5G being so disaggregated and being so open and open source based is mainly because it is designed for connected industries, meaning it is designed for addressing multiple different use cases. So even in this, you have a signaling plane, in other words, control plane, and also the user plane for data call or connecting an IoT devices for some IoT applications and so on, right? That's the key thing that I wanted to share. And the other couple of slides, 2 or 3 slides, I wanted to talk and then hand over it to Yokesh, because it's kind of going to set the stage. So we talked about devices, then radio access network equipments, transport network equipments, core network equipments, and then OSS BSS equipments, right? And then you can have a lot of applications, AI helping the network, blah blah blah. So many things that you can have, right? So now these are all different things that makes up the blueprint. Now, when it came to 5G architecture, there's two types of architecture is available, right? Today, one is a non-standalone architecture, another one is a standalone architecture. So what we are going to really focus in our session for Magma is a standalone architecture. I mean, decoding zone.5G is a standalone architecture. Now, what's the difference between the non-standalone and standalone architecture is, we know that there's a lot of investment has been put in 4G. So you don't want it to just take it and throw away. And it never happens in the industry like that. You always introduce a new technology in the pocket areas where it makes more sense. As an example, multiple 5G, multiple people or machines having 5G SIMs. Maybe in that area, it makes sense to deploy 5G and not in every other areas, right? So that's how in every technology happens. And when 3G was there, the 4G was deployed a pocket and then slowly migrated into full 4G. And similarly, it's going to happen for 5G. So in order to facilitate that, what they did was they introduced something called as a new radio. That's nothing but G node B, right? E node B, E is for 4G, G is for 5G. So these are the two things that they introduced in a way that this both E node B, which was anyways talking to the 4G core network, which is EPC. They also made the G node B, which is 5G radio, talk to the 4G core network. So that is what it is called. That architecture at a high level is called as a non-standalone architecture. So only on the radio, you introduced 5G and core network was still 4G. Okay. Then standalone architecture is an architecture where they said, okay, I'm going to create a new 5G core network. And now this new 5G core network is going to have all those beautiful things in this world, which we will learn in subsequent sessions, right? It can be developed as a microservices, disaggregated. It can work in virtualization, VMs, containers. It can scale up, scale down, all the benefits of the cloud. And it can handle the speed that is defined by ITU, 1 Gbps throughput, 1 millisecond latency, and etc., right? So that's what it is. So they started defining this 5G core network, and then this 5G standalone core network was connected to the E node B and G node B. In this case, the EPC is not there. Everything is connected to the 5GC. But in real deployments, you can have a mix of both, and it depends on how you want it to really design. There are multiple ways of designing it. You can design and deliver the solution to your end customers. But in both the cases, the key message here is that it has to be seamlessly move between different technologies, 4G to 5G, right? If you see below here, if the UE moves into the 4G area or to the 5G area, it should pick up that signal, and then the call and everything should happen in that area, and vice versa. So this is a very important concept you need to understand, non-standalone and standalone. Why? Because standalone is an architecture that we will be focusing in the rest of the Magma sessions. So now, when you also look at it, there was a N architecture. I like to say it like this, even though different people say all N architecture and service-based architecture. So N-based architecture is basically a reference architecture for voice calls, right? Where AF is normally the IMS, and service-based architecture is basically all that beautiful HTTP, all web-based technologies, right? But even in that, they kind of split it. So some of the key entities like UE, Radio Access Network, UPF, these are all still had those N interface, but anything above that, everything became a service-based interfaces, right? So what does it mean? There is no real protocol. It's actually, no, I'm sorry, I shouldn't say that. There is a protocol that's there that communicates between all these different devices in the core network. But what's important to understand, it's a service-based protocol, meaning it uses HTTP, and you can define, you can subscribe, desubscribe like a normal web program, right? To get the details, pull the data, and communicate it depending on JSON or even HTTP body, right? Different types of bodies, XML, JSON, and so on, right? So that's what the service-based architecture. It enables flexibility. It enables easy development. And reduces all the time that we traditionally take to build network equipments in olden days. Okay, so those are the two kind of architecture that I wanted to kind of have you understand. Now a little bit more into this of mapping this, right? This is a nice slide, but now you still have a little bit more number of network functions. But if you understand this, it is good enough, right? So if you know 4G technology, whatever the HSS is, in 5G, it is called as AUSF, right? Whatever MME was there in 4G, it is split into two functions in 5G, AMF and SMF. And whatever was there P gateway in 4G, it's kind of split the control plane of the P gateway and S gateway, right? You had an S gateway and P gateway in 4G. So the control plane of the S gateway and P gateway is called as SMF. The user plane of P gateway and S gateway is called as a UPF. And you know the DN, right? It's internet, voice, or some other servers and so on. These are all the some additional functions here. PCF is equivalent to PCRF in 4G. UDM is equivalent to HSS, which keeps the subscriber data for 4G, right? And AUSF is for the authentication. AMF, SMF / MME is for call control, right? UPF is for the actual user plane transportation. AF could be, an application function, it could be IMS or some data server, AI server, whatnot, right? So, these things, it's easy to map. And principally speaking, most of the things, it does the same thing as what 4G delivers with some minimum extra. But the most important thing is it's all service-based, which has a tremendous advantage to do a lot of things, right? When it comes to implementing and deploying it for different use cases. Now, there are some new network functions. There's some additional network functions, but for the simplicity, right? There's some new network functions is added in 5G, which was not at all available in 4G, right? So, I mean, I wouldn't say that, right? In 4G, there is something called as an SCEF, which is equivalent to the network exposure function. So that's not completely true. I take back. But anyways, whatever that you see in the block here are some of the new functions that you would learn and you would see in 5G. The first one is I'll go with easy ones, right? Network exposure function. So basically opening up core network with an API for the developers to leverage the core network and do it. Like, for example, when they have a data ready to send, they can call an API to send the data from the application function, for example, right? And the UE, the UE device, what do you call, app that is available, can also be built and communicated towards the app that's available on the server side. And because it knows the status of the network and it can get a lot of intelligence about the core network, the logic can be created in the application in such a way that send the data at the right time, contact the person at the right time. All those intelligent logics can be added in a way that it's going to be very useful for applications, and it optimally uses the network if you design it right? So that's network exposure function. Network repository function is, like I told you, all these are the service interfaces. So when there is a lot of service interfaces are available, service-based network equipments are available, they have to actually, some kind of a repository has to be maintained, which lists the list of different services that's available in this network and the lifecycle management of that services, right? So in order for you to do that, this network repository function that keeps all the different services will be very helpful for you guys. Then the third one is network data analytics function. This is very, very important, right? In the past, there was no standard-based analytics. There's a lot of companies like Viavi and many other Spirent and many others basically build their own proprietary through probes, passive or active probes to monitor the data, extract the data, and look at what's happening in the network, take corrective actions, closed loop, zero touch, all those things that we talked about. It was done in a more proprietary way. But in 5G, they introduced a standard way of collecting the data and standard way of dealing with data. And also on top of that, you can also build an app to do AI ML for the different use cases that happens in the network and also in the applications. So the network data analytics function is for that pretty much, right? It's introduced. And the last but not least, network slice selection function. I am going to skip this for today, and in the subsequent sessions, I will explain you. At a very high level, think about a network can be divided into multiple different small networks. for specific purpose. One for browsing internet, one for doing IoT, one for streaming 4K video or 8K video, or one for one enterprise, another one for another enterprise, right? So for the service-based, app-based, enterprise-based, the number of ways that you can slice. And you can slice the core network, you can slice the radio network, you can slice the transport network, and even you can not necessarily slice. Maybe you can have multi-tenant of OSS, BSS. That's the right way to use it. Or if you consider that as a slice, you can also say, hey, I have a slice for everything, right? If you like in a case where you wanted to be a reseller to some enterprise who is trying to sell it to their customers, then you also have to provide OSS, BSS to them, right? So you might have to design your system in such a way that either it's part of network slicing or is it kind of a tenant based login and password that you will provide it to your end customers. Okay, I'm going to stop here. Now, the last thing is, Yokesh, are you ready?
Yes, Karthik.
Yes, I trust you guys have heard me that. Let me just quickly hear. This is the Magma architecture. So now what we are going to do is in every session, we are going to get into the depth, right? So today I took a little bit more time, but I'll try to make sure the first 10 to 15 minutes is what I talk, giving you every session some kind of a new technology. And so you can connect the things end to end, but we will start getting into the details and start learning Magma real from today, right? And what is Magma? Magma is an open source converged core network, as simple as that. And because it's open source, there is no barrier to the entry. In the past, for small companies to deploy any core network, it used to cost them hundreds and thousands of dollars. But now you can do it in just, millions of dollars. Now you can do it in hundreds and thousands of dollars, right? It still costs. A lot of people think open source is free, but open source is not free, right? You can't really take the open source and deploy it, and you can configure it and make it run, right? But something goes wrong, then you need to really have experts to really support you who has actually done the coding into those open sources and know how to fix them. So, it's barrier to entry. At the same time, it's not free because people work on it and people has to be fed and whatnot, right? But what is more important is that because the barrier to entry is smaller and there's a lot of the cost is also comparatively smaller when you buy a proprietary core network, you can actually use this core network for a number of different use cases. And Magma, to my understanding, is created for edge-based use cases, and it's architected so nicely that you can create multiple access gateways connected to the management entity, which is orchestrator / NMS, and you can manage all the multiple different access gateways that you provided to the same customer or to multiple customers. It doesn't really matter, right? And this Magma Access Gateway supports LTE, Wi-Fi, and 5G. It also, in 5G, it also supports NSA and SA. So NSA is nothing but just 4G core network, okay? And like I mentioned, and 5G with some additions. 5G SA means completely new network functions. So it supports all the three, but what we will be focusing is on only 5G. And another most important thing is the federation gateway. This is the third component of Magma. So in case if you wanted to leverage the operator subscribers and provide them service in your network, then you can always connect to the operator's network through the federation gateway. Why would you connect to the operator network? Only for three main reasons, right? 3 or 4 main reasons. The first reason you need to connect to the operator network is if their user roams into your network, let's say, you need to make sure you authenticate this user is the right user in that core network, right? So authentication related stuff has to be taken care of, like AUSF, UDM, and things like that, right? Then the second most important thing is policy. If this user has bought data service or if this user has bought IoT service, depending upon what he's bought, that has to be enforced. So the policy is the second critical component that you need to connect to in the operator network. And finally, charging, how long that user is used. You got to somehow report it to the core network. So when the core network, MNO network, so that MNO means mobile service operator, like Bell, AT&T in US, Airtel in India, and so on, right? So that if they have this piece, the policy, user-related data and charging, they can actually ensure their subscribers are roaming into the private networks like us, and still they are able to monetize it with the local operators. MNO can monitor it with the local operators, right, or the edge operators. That's the key message I wanted to give. And finally, for one more reason, you need also connect to the MNO network is for roaming, right? These are all is very easy to understand. It's not a difficult thing, right? Policy is required. First of all, authentication data is required. Policy is required. Charging is required. And fourth one is roaming is required. Once you have these four things connected to the MNO core, then you will be able to allow the MNO core's subscribers to roam into Magma and vice versa. And mostly it is the subscriber from Magma going to subscriber from Magma Magma used by the subscribers of MNO network is the typical use case of this federation gateway. So if you look at this as a whole, you have a radio network, you have a core network. Obviously, these are connected by the transport. Then you have three in the core network. You have three architecture: Magma Access Gateway, Orchestrator for NMS, which is for the management of it, Federation Gateway, which can connect it to the MNO network. So now I'll pause here for any questions before I hand over it to Yokesh. I want to really set the stage so you know that we are going to start getting into the details of Magma moving forward. I'll pause here for any questions.
Hello, Kadir. Thank you for the presentation. I just wanted to ask about the access gateway, the Magma access gateway. There are some functions I cannot find in access gateway or MNO, like NSSF and NRF. So this is part of Magma access gateway, or this is also connected by Federation gateway to the MNO?
So it depends on what use case that you're trying to do, Ahmed, right? From the open source community point of view, we are, right now it's we have this AMF, SMF, and UPF, right? And all the policy charging and everything is the internal data. We still don't have for the 5G the Federation gateway built as such, right? It's mostly a standalone network, orchestrator NMS, and if you want to deploy any FWA private networks, you can already do that with the minimum functionality, of course, right? As you know, the technology always continues to continue to evolve. But what we are also looking at it, trying to understand what other use cases need what and why, right? So Ahmed, which company do you work, Ahmed? Just to curiosity. Where do you work?
I'm working, recently joined for Orange Labs.
Awesome, awesome. So yeah, maybe you and me can offline discuss on this in the Slack channel. Are you in the Slack channel?
Yeah. Sure. Okay, let me drop you a message.
Yeah, let's discuss and then we will see what's your use case, how we can structure it, right? So one of the use case that we're seeing is for NEF. Because I'm under NDA, I cannot share it. NEF seems to be a little bit a good use case. When it comes to the network slicing, we are still, because this is an edge network, right? This edge network supports like 1,000 subscribers. Right now we have tested for 600 subscribers. And does it really make sense to slice it, or should we just say one A gateway will be assigned to one slice, or multiple A gateways will be assigned to one slice? So those are the, and now do we have to implement NSSF inside or outside? External NSSF will control Magma. Those are all the discussions under, those are the things under discussion and debate. But always talk about this offline. You know me how to, you know me already. I'm sure that Magma 5G meeting in Magma that I'm organizing, I remember I seeing you. Maybe I've misunderstood. So reach out to me. Let's talk offline there. Yeah.
Okay. Thank you.
But by this one, this particular event is a joint event by the volunteers to help learn Magma, right? That's this event. And maybe in our next event, right, after this 12 session is complete, we might start for Open RAN as an example, right? Or SDN for transport. So those are the thought process that we have. But this session is basically to learn Magma, because that's one of the open source available for us. Otherwise, you got to work in the big companies, right, Ahmed? There's no way
Okay,
to
thank you.
no way to learn the core network. Yeah. This is good. So at the same time, you'll also learn number of technologies, how all these different technologies come together. We will work on it. But with the interest of time, I will hand over it to Yokesh. Yokesh, if you cannot cover your stuff, whatever you prepared in 30 minutes, don't worry, right? You can always cover the missing piece in the next session. Okay. With that, I will give the hand over the session to you, Yokesh. Please go ahead.
Thanks, Karan. Hello, everyone. I just share my screen. Give me a second.
Am I seeing right? Kishore is joined. Kishore, Kirod, are you there? Yeah, go ahead. Hey, Kirod, how are you? We should talk.
Yeah, I'm fine.
Lot of good old friends. We need to talk. Let's get started, Yokesh.
Sure. Yeah, so today what we are going to do is I will walk through the steps on how to install Magma as a Debian package and how to integrate with open source GNB and UI simulator, which is provided by OAI. So this is a high level overview of Magma modules. Yeah, again, as Kader said, I don't know how much I can cover, but I'll try my best to at least show a working demo. But let's see how the time permits. So these are the modules within Magma, starting from HTTP, and we have the EPC and the 5G. So Magma is having both 4G and 5G functionalities, and the external interfaces N1 and N2, they talk to GNB, which will then connect to some CPU device or UI device. So the UI device via GNB will connect to HTTP, and then the calls or the UI will get registered in AMF. And once the UI is registered, authorized, then he can ask for creating a session. So in 5G context, you might not see exact nomenclature as used in 3GPP spec, but yeah, I just tried to map some of it, like UDM is subscriber database, SMF is session management. So whenever a UI wants to create a session, first it will authorize by UDM and AUSF. Then as soon as it wants to create a session, let's say it wants to go to google.com or yahoo.com, it will create for a session request, which will then land in SMF, and then the fastpath resources will be allocated. And then if everything goes through, via N3 interface, the GNP will directly send a message to the fastpath, which will then go to the internet. Yeah. So just to want to give a quick intro. So this is how our topology is for today's demo. On the left-hand side, we have Docker-based image for OAI. We are running a simulator GNB and a simulated UI. And then this is connected to Magma. So Magma will do all the authentication and session management. And then once the session is established, it will create a fast path towards internet. So this is our topology for the demo. So yeah, I'll share all the links and the details, but just to give a high level overview, this is the Docker compose file of the OAI. Here we can see the MCC, MNC, the way it gets connected to AMF and the other configurations. So on top, you can see this is a GNB related configuration. And in that line number 30, we can see all the UI related configurations, like the IMSI, the authentication key, the website it wanted to access, the DNN it wanted to access, and things like that. All these steps are documented, but just to give a high-level overview, on left-hand side, we are going to launch a VirtualBox-based simulator where we are going to install Dockers, and then we'll fire up the GNB and the UE Docker images, and then we'll bring up the Dockers for connection. On the similar lines, we are going to bring up a VirtualBox for Magma. We are going to deploy the package, and then we are going to run the configuration. Now, we were kind of trying to debate how much we should cover in the session. One way is via orchestration. You have a GUI where you can connect to the GUI, add the subscriber, add the policies. But that itself fitting in one session was very difficult. So what we thought was we will just show a mode of AGW where it runs in headless. So headless means it will not be connected to any external orchestration. We will have a equivalent CLIs which we can use, let's say to add a subscriber, create a policy, and things like that. So we are going to use a combination of the headless mode. Yeah, so this is the packet capture, what we are going to see. So this shows the initial set of messages. The first message is to set up the connection with the GNB, the radio device, and then the subsequent set of messages is to show that user needs to be authenticated, the authentication is successful, then couple of security modes, then some context setup, and finally the PDU session creation. So PDU session means user is authenticated to use the network with some default policies, and now he can browse the internet. Okay, so all the details of this are available in the Wavelabs GitHub. It is there as part of the slides. So we have.
Yogesh, is this a public repository for everyone can join?
Parthiban, I'm not sure, but I think it's a public repository, Kadak, but let me just double confirm with Parthiban.
Sure.
Yeah.
Yeah, important, right? To make sure. And at least let's focus to see if the installation is installation part is done today, right? So that you can take them through step by step. I'm not sure if you have planned it, right? Step by step, so they know how to install. It's a good start.
Yes,
So play around.
Yes. Yeah, we'll do that. We are planning to do that. Yeah. So I just recorded the session because the installation step goes beyond 40 minutes, around 40 to 45 minutes. So we have recorded the session, and we'll be sharing the details. I'll skip some of them to go fast forward, but all the details are captured here. So if you go to the first folder, Magma 5G enabler, so it will tell all the steps related to launching of the VirtualBox and the commands which we have to use it. We'll go through one by one. And then this is the OAI GNB enabler. So we have a Vagrant file which will tell how the VirtualBox will look like. Then the launch commands. There are a lot of manual process in this, but we are planning to have Ansible-based scripts also, which at least some of the steps will be automated. The Ansible scripts are ready. It was just that we have to test in a couple of systems before we share it with all to make sure that it's it goes hassle-free. Yeah, so whatever steps we will improve upon based on the Ansible scripts. But I think these steps will give a step-by-step process on how to install, and if there is any issue, how to debug it. Yeah. Any questions till now? Otherwise,
so the step-by-step instruction, that the video that you have will be uploaded as well.
Yes.
In addition to this session in the YouTube, right? Okay.
Yes. Yeah. Meaning we have to do still some editing, Kader,
Okay.
because it is going a little bit beyond, uh, like some installation is ongoing. We have to cut it short so that it becomes more exciting to watch through. But yeah, the videos are ready. It is just the editing we have to do in upload.
Got it. Nice, nice. Yeah, it would be good to really see at least the simulators installation today. Yeah, please go
Yes.
ahead.
Yeah. Okay. So we have actually made two videos. So this is kind of a rough, a complete raw video, which I try to fast forward it. And then we have a video demo where we are tagging each and every step so that you can match the commands and equivalent step. And if there is an issue, how to debug it, things like that. So I'll start with the simple one, the raw one. I'll try to fast forward where it seems, it's time taking. So yeah, so this is the step where we are cloning the Magma repo, the Magma installer and the OAI installer. And then we have this is to fire up the Vagrant. So all these are already uploaded in the GitHub repo, which I showed. Yeah, so now we have launched Vagrant of Magma. This is the Vagrant for OAI. Yeah. Maybe a little bit fast forward because it's a little time taking step. Uh, so this is the Vagrant box coming up. Uh, okay, so I think the Magma distro is up. So one thing which we have to do as part of Magma installation is, as a starter, it is good to rename the interfaces as ETH0, ETH1, ETH2, because a lot of default configurations uses those interface names. Of course, it's not mandatory. We can still play around with YAML files, but because it is easy to start with ETH0, ETH1 naming, so we'll do that so that you don't have to modify a lot of things in the script. So the steps are there on how to change the name and things like that. So I just quickly jump forward. Okay, so we have changed the names and now we are ready to install the real Magma. So this is, we are pulling the 1.7 Magma repo. Yeah. So this installation is ongoing. What we are going to do is I just skip it over because this is automated process, nothing much to do. I think we'll go to the OAI part. So this is, meanwhile, the Magma system is coming up. We will keep our GNB simulator, will install our GNB and the UE simulators provided by OAI. So for that, we have to install Dockers. Yeah, so I think, yeah, Dockers, I'll still fast forward. All the commands, all the instruction, the reference links, everything is there in the launcher guide, the launcher GitHub repo. So I think I just skip to the on how we actually fire the simulators. Yeah. So now our basic Docker is up. This is the first Hello World program, just to make sure that everything is okay. Yeah, it's the Docker Compose. Now we are about to launch the GNB and the UE simulators. The first step is to use the Docker Compose. So the Docker Compose file have the interface IP address, which will connect to Magma, the MC configuration, and all the related configurations are inbuilt in this Docker image. So until you are using the the uh, default values, you don't have to modify anything. Everything is pre-built in this Docker image, this compose file. Okay, so now we are pulling the GNB repo of the OAI, the Docker image. Yeah. I just because just yeah, it just does the installation, nothing much. Then we are pulling the UE image, the Docker-based UE image from OAI. So we will need both the images, one for simulating the GNB, one for simulating the UE. This is, we are tagging the image so that the private image can be changed to the public image. Yeah, so the installation of Magma is ongoing. So at this stage, we are the OAI, GNB, and UE is ready. All the images are pulled in. Once the Magma comes up, it is just we have to fire it, nothing else. I will just quickly move it forward. Yeah, so the initial step of Magma, it takes a little bit time because it installs a lot of packages. So by default, Magma comes with 5G disabled. By default, 4G is enabled, but the 5G is disabled. So what we are going to do next is we are going to enable all the flags which will turn on the 5G. Again, as I mentioned, it's a headless mode, so we can do it from the CLI. But in the actual use case, you need to do some Swagger APIs connected via orchestrator. Yeah, maybe it's we will cover it in our subsequent sessions, but we just keep it short. We just did the CLI based approach. Yeah. Yeah, so this is the main file, which drives the overall configuration in Magma. What we are going to do is we are going to have the 5G feature enabled to true. So for AMF, SMF, UPF, and subscriber DB, we'll turn it on. Here I would have multiple times, but if we use the Swagger, it is just one time effort. So this is the 72499 is the MCC MNC we are going to take. And this works on some default slice configuration. So we can see that 5G features are enabled. This is the MCC MNC. There are a couple of steps we have to do for the first part. We have to give the IP addresses to connect and all. But again, if we are using Swagger, we don't have to do it. It is just because we are using the CLI, we have to do it. So I just so there are some paging configuration. There are some paging related timers, the UPF node identifiers, which are specific to 5G. We have enabled it. Again, all this information is present in the GitHub. So in this installation, I'm just showing you in case if something is hung, something is stuck, how you can recover it. Mostly it should not happen, but just in case, if you see that some service is stuck, you can just kill them. So now all the 5G services.
Sorry, Yokesh, just sorry to interrupt you, right? If they have to follow this video and if they have to install everyone attending in this session by themselves, so what kind of resource requirement they need? Just a laptop
Yes.
with Vagrant is okay, or?
Yeah. So laptop with Vagrant is okay, but if you open the Vagrant files, you can see the kind of requirements. So for Magma, we need at least 6 GB, 4 cores. So because meaning then only we'll get a better throughput. Of course, people have tried it in the lesser CPU, but this is a general recommendation. And then for OAI, also I have kept around the same configuration. But yeah, here we can play around a little bit because I have a lot of packages. I've kept it 4 CPUs, but we can have 2 CPUs with like 4 GB. But this is, meaning I think minimum it will be like i7 or a little bit high end i5. I think that should work out. But local laptop is also okay. No worries. If we have enough CPU and memory, we are good with local laptop as well.
Okay, thanks. Hopefully it is helpful. Before our next session in 2 weeks, you guys can try it out. And in case if you have some troubles, you know where to reach out, right? Wavelabs 5G Slack channel in Magma Slack. Yeah, good. This is good, Yokesh. Yeah, at least I want to make sure today we have 5 more minutes. Installation is complete, right? So that next we can look at calls. Yeah.
Sure. So yeah, I think we are almost done. So this brings Magma with 1.7 release, which is the official release for Magma, and we can connect the systems on top of it. So this is restarting of the systems. This is just to make sure if the services are up and running. Oh, sorry, I think it was a little fast. There was a spelling mistake, so yeah, a little bit of editing is needed, but yeah, this shows if the system, the MME service is running. On similar lines, we have other commands to check other services, but this was to show that everything is up and running. This is to add subscriber. So the subscriber is added with some default MC. Again, if you follow this guide, all the default values are there, both in compose file and the commands. So theoretically, you should not need to change anything. Yeah, and this is just to show that in case if you don't want 1.7 repository, if you want master repository or the latest 171 repository, how you can do it. So, this is that artifactory, you have to go and change. Okay, yeah, after that it is just apt update and install. Yeah. So, I'm just sliding it fast so that, yeah. So, yeah, with this, so what we have done is we have prepared a Vagrant machine. We have renamed the interfaces. We have kept the required configurations to enable 5G because 5G is by default disabled. We have seen how to add a subscriber. And after this, we are ready to go. Meaning we can just launch Magma and then, it will connect with the OAI GNB. So I think, just for the lack of time, I will not have I will not be able to show the end demo, but just to give a flavor.
No, but we can continue this demo in next one, right?
Yes,
just
yeah.
give a recap and you can continue. But
Sure.
one of the question I have is, what is this OAI? Is it a simulator? I know OAI is a open source, another open source community, which is open air interface, right?
Yes.
Yes. So what is it? Is this a stuff that they have created? What is it?
Yes, right. So OAI, GNB, and UI, these are the stubs simulators for simulating the GNB and the UI, which OAI has created. It's an open source, and we can use it to verify it with Magma. So yes, it is a GNB and the UI simulator.
So it basically means that it works with so two different open sources are working. It's not the same open source stuff. That's really good.
Correct. So if you see the, if you see that, if you assume the blue color building is some CPU device, so this is again an open source. This GNB is again open source provided by OAI, and the rest of the stuff from HTTP to the UDM is Magma open source. So this is two open source in action. Okay. So pretty much we are done with installation. It is just, we have to fire it. And, I will just directly jump to the last part because, there are a lot of steps involved. But it just to show that that everything is up and running. So we are again back to the the OAI simulator. It's, I think, it is a lot of back and forth we have to do between windows, but yeah, that's how it is. Yeah, so we have launched a GNB. So this is open source GNB in action from OAI. And this is the UI which is launched. So it's like our handset. So now if everything is okay, we should be able to, send the traffic to the internet via AFF or via the Magma core. So I will, so yeah, so so if we see this OAI tunnel, so this is the GNB node, and this is the tunnel which gets created towards Magma core, and then finally we are pinging to 8.8.8. Uh, what we wanted to show was finally we are able to ping the 8.8.8 via 128.12. So this is the UE IP address which is assigned by Magma. So UE by itself will not have the IP address. As part of the negotiation or the session bring up, we will assign the IP address. So what we are saying is go to 8.8.8 via the source IP of 128.12. Yeah. So this almost brings to the end of the session. That was just last command. Now, how to prove that it is using Magma? Yeah. So there are some fast path commands of OVS. Of course, there are packet captures as well, but then this is one quick way. So these are some fast path counters which we can see implementing to make sure that it is taking the correct path. So we have other demos also where where the team has tagged one by one steps to the command, so that it becomes very easy to navigate through. We will do some editing and we'll upload it.
Yeah, but we can also go through in our next session, right?
Yeah,
okay.
Yeah, of course.
So yeah, if we can put this today's recording and also point out to this recording where it is, we can put the session demo dot whatever that file name is, the naming convention. Then I would sincerely recommend every one of you to try it out, follow through this, try it out, and if there is any questions, if it doesn't work, again, you can reach out to us on Slack channel. We should also put this in YouTube and put this video in the Slack channel of Magma Yokesh, right?
Sure.
Like if someone wants to know how to, install and OAI, UE, and Gnode B with Magma headless, right? This is the demo, so we have to do that as well. So the community also can benefit from it.
Sure. The steps is there in GitHub. Yeah, just in case if they're having any issue, they can follow through the demo video. But the steps are the same steps we are using for the demo as well.
Sure. But and we also want. Yeah. So let's put this recorded video and the demo video into the YouTube, and also let's make sure that the GitHub that you have, is it public or not? If it is not public, then we can create a public repository and we can post it, right? Either in desktop or public repository, or we can figure it out.
Sure.
All right. Awesome. Good job. I know that 5 minutes we are away from our more from our scheduled time. As you know, we try our best to keep it within the time that we always wanted to do. Thanks for joining, and I sincerely recommend that you guys try it out, every one of you. So in our next session, whoever is tried out and show that it is working in your laptop for first 5 minutes, will try to surprise you with some gifts, right? So that's going to happen in our next session, which is going to happen in 2 weeks. Do not forget to copy all the links that's there in the chat so that you can join next, next session, which is going to start in 2 weeks. I'll pause here for any questions, and everyone feel free to leave the session. Those who wants to stay back and discuss, feel free to stay back. Thank you, guys. Take care. Bye-bye.
Yeah, thank you.
Nikki, you can stop the recording.
Yeah, stopping it.
So, Kishore, how are you?
Yeah, I'm fine, Kadir.